I am hoping to get my homemade helicopter in the air again after 2 years of being on the ground. In the last video I tested my new driveshaft to near full RPM, and I'm happy at this point to continue on to the next stage. It now needs to be tested with the blades on and at full power. This is going to be happening in this video, but first I want to show you what else I've done in preparation for this test. I have made a shroud to encase the driveshaft should anything break. What I've made is lighter than what I had before, and this is what I try and do with everything I redesign. I want to solve problems in a way that results in something that works reliably, but it also reduces weight. Reducing weight is very important to me, as 2 to 3 years ago the machine was hovering near its weight limit. This meant that the maximum height I could achieve was only around 2 feet. It needed the efficiency of ground effect to hover. That's not to say it wasn't capable of flying a few hundred feet, because any helicopter that can leave the ground is capable of flying at height with the addition of translational lift. This is why any gust of wind causes more lift. You suddenly ascend as soon as that happens. Operating in very low wind is a must, particularly in my machine, which is slow to react to sudden increases in lift. Ground effect can increase the hover performance by 10 to 20% depending on the terrain underneath and height above the ground. Before the disaster video I had already reduced the weight by 9.5 kilograms, but I never got to see what the new maximum height was. 9.5 kilograms is quite a lot, and it could have made a significant difference. Since then I've been reducing the weight further by at least 2.8 kilograms. I also didn't get to check the new flight duration with the bigger cooling fan. I would love to find out what difference these changes have made, but it all depends whether my new driveshaft will work. There were concerns in the comments about the bearings in the driveshaft, and I share this concern. There could be a solution to this issue, but let me explain the situation. This is the needle roller in question, and it has 11 needle rollers inside. This is a diagram of how I'm using it, and this is a diagram of how it should be used. We can see that the way I'm using it, we've got 28 kilograms all going onto one needle roller, whereas it's supposed to be going into a block of material, and therefore at the 28 kilogram load that I've drawn on the shaft there is supported by around 5 needle rollers. And if we look at the static load, we've got 4,050 newtons, and that equates to 412 kilograms. That is the maximum this bearing can take. So if we divide that 412 into 5 rollers, we get 82.4 kilograms. So I think that is a sort of a safe load, really, because actually this needle roller will be taking most of the load, and these will be diminishing loads. So I think 28 kilograms on one should be okay. There was some concern about using this type of needle roller, and I've got concerns too. But from the theory, I think it could work. Here is a potential solution. On the left, we have the 11 needle roller bearing, and on the right, we have 22 needle rollers. And that is going to help share that load. If we draw more needle rollers around there, that contact patch could potentially be shared by 2 rollers. Maybe there is a case for at some point it's only loading on one, but there is a chance that if this doesn't work, then the needle roller with twice as many needle rollers inside could work. Another option that was suggested in the comments was to try a slider. So something low friction, something kind of that shape. If the friction between these two surfaces was low enough, then that could be a solution. I've changed these connectors from bullet to spade, and I've mounted a brace. I'll show you why in the next clip. Notice how much the regulator is moving up and down with vibration. You know, it's funny. You go through this project and you're all excited about the end result. You know it's going to be an incredible experience. And you put the blades on, and it's at that point you realize, I'm totally crazy. I must be absolutely nuts. And it becomes a little scary. So you give it a few hours, getting used to the idea, and then you kind of go, meh, you'll be fine. Now the point of today really is just to spin this drive shaft up under load, and I can only do that with the blades on. If the testing goes well, then I have got the extended skids on, and I might try and do some hovering, but only if the testing goes well. There are concerns about the bearings, as I've mentioned, and we'll just have to see if any kind of binding starts to occur. I should be able to feel that. I'm just going to do small tests and see how it goes. In the disaster video, there were lots of teething issues in that day, and that's because, you know, I spent the whole winter working on it and there was lots of little niggles to sort out. I'm expecting the same again today. During the test I did without the blades on, there was some sort of fueling issue, and it could be pump related. That is actually a new pump I put on 2 years ago, but it may not be. I just have to see how that goes. The starter recoil I've fixed, I hope. There was no other way to solve it other than to heat up the shaft that goes up through the middle, and that plastic there just melted onto it a bit. That was the only thing I could think of to kind of solve it, because it was spinning on the shaft. That might let go and stop today. I don't know. I've started it, but we'll see how the rest of the starting goes. I think that's enough talk, don't you? Let's get it outside. There you go, almost straight away. Why does everything work fine in the workshop, but then stops working as soon as you try it in the field? See how the plastic has split? All I can think to do is remove a bit of the webbing and try and get a Jubilee clip to tighten onto it. JLCMC have sent me some hinges to finish the driveshaft shroud and are the sponsor of this video. JLCMC offers nearly 600,000 products, including mechanical parts, drives, transmission, linear motion, fasteners, hardware mechanisms, electric motors, sensors and switches, electronic controllers and pneumatics. Find the part you want, in my case aluminium hinges, find the size you require from the table below, select the size on the left and the surface finish, select the postage and add the quantity to your cart. The package arrived quicker than predicted and the price was excellent. These hinges are just what I need to finish my shroud and look to be great quality. I also got some solid carbide milling cutters which you can run at 3 times the speed of high-speed steel. They are less than half the UK price, so that is fantastic. The hinges I received are strong and only weigh 30 grams each. My plan is to weld them to the shroud like this. And there we are, perfect. Check out the video description for a link to the JLCMC website and special offers. Thank you very much to JLCMC for the products and sponsoring this video. The shaft is contacting the shroud here. I've just added a spacer to try and increase the clearance. That can be an issue sometimes. Safety features with all the best intentions turn out to be the cause of a failure. I intentionally made the shroud close to the right hand side at the top because engine torque causes the shaft to move to the left, but I've obviously made it too close. You can actually hear on this test there was still slight contact. I'm just going to run it with the shroud open. I did weigh up the risks of doing this. The full encasement of the shaft is safe, but only if there isn't contact. If there is contact, then you could argue that it's safer to run without the shroud. Number 1, the lower belt was ratcheting. Every click is a tooth skipped. I need to realign the rotors and tighten the belt. Unfortunately, I cannot hear this when in the machine. Number 2, the engine developed a misfire, but I cannot investigate further because the pull start is slipping again. It is time to call it a day and solve some issues. For next time then, I've got to sort the engine misfire. It sounded like a misfire to me. It just sort of cut down to one cylinder. Not sure what's going on there. Could be a coil, could be spark plug related. Hopefully it's something fairly simple. The starter recoil needs to be fixed. I think if I made sort of like a collar that was a press fit onto that plastic, maybe that would work. I need to sort the shroud out so that it's not touching anymore. Sort the belt tension, sort this bar, find out why the bracing isn't working as it should do. There's a little bit of play in the controls, not a lot, but a little bit I'd like to get rid of. And also I quite like to rebalance the rotors because there's a bit more vibration than there was initially, and that's partly due to a weight I had. It was a piece of wood in the end of the rotor. It came off, and that was a year or two ago, and I made another one, but I didn't note the actual amount of grams I should be putting in there. I had the dimensions, but I didn't have the weight, so I just remade another bit of wood the same dimensions, and obviously the wood varies in density, so it's not quite right. I need to take them off and rebalance them. Overall, I think I'm fairly happy. There was no issues I could detect with that drive shaft. It seemed alright. I mean, I only lifted off the front just about, but that was enough to kind of feel there wasn't any resistance to moving the rotor. It didn't seem like there was to me. So I'm happy with that drive shaft at the moment. I did have visions of hovering like I did in the past, and I guess I'm slightly disappointed that I didn't do that today, but it wasn't realistic. I shouldn't have been wanting to get that far. There was a comment in the last video about getting some vibration measuring equipment, and that would be very nice to have, and I hope at some point that I'll be able to get that. The cheapest I sort of found secondhand on eBay was about £1,000, so it's not exactly cheap equipment. Definitely something to aspire to. But something I have acquired is this, and this is a tensile testing machine. It's been left outside for a lot of years. How it works, you've got a big piston in there, pushes these rods upwards, it's connected to that, and you mount whatever you want to tensile test between those two. You've got like wedge jaws for gripping things, and you measure the pressure using these gauges, and despite their look, they still actually work. And the pump works, the motor actually works as well, but it started to smoke, so I'm going to use a new motor. The piston still moves, everything's fine, despite being left outside for so long. You can also do compression testing as well. You can also mount, like say you want a bar going across there, see these little bits here and here. There's a scale going along here, so you mount those according to what distance apart you want them, and then you can do some bending, and that will be useful as well. It's only rated for about 20 tons, and the scale is in, the black is in PSI and the red is in tons. I don't know why there's two gauges, maybe it's just to check they read the same. It would be nice to do some destructive testing of things like blade straps. I think to achieve building a machine from scratch that is extremely reliable is a very long development process, and perhaps one reason you don't see home-built helicopters staying in operation for long. The enthusiasm to continue with this process for years is something not many manage to do. I don't know if I've got what it takes, but for now I'm certainly enjoying myself.